this, we will understand about the very first queuing model, which is MM1, FIFO, infinity, infinity. So the first two M's denote that the probability distribution of arrival rate follows Poisson distribution. Second M also denotes Poisson distribution, but it addresses about the service rate. The third letter 1 denotes that it is this particular model has got a single server. FIFO denotes that the service discipline or the queue discipline is first in, first out, or first come, first serve, or you can also say general discipline. The third letter, infinity, indicates that there is no restriction in the number of customers allowed in the system, allowed to be present in the system. The last infinity letter denotes that the size of the calling source population is infinite. Let us move on. What are the various parameters which can be measured for this queuing model? One is we can measure the probability of having 0 customers in the system, which is denoted by P suffix 0, which can be calculated as 1 minus rho. We know rho is nothing but the utilization factor. So when I subtract it from 1, I will get the unutilized part, which is nothing but the 0 customers only. Then we can find out steady state probability of having n customers in the system as P suffix n is equal to 1 minus rho, that is P naught times rho to the power of n, where n is larger than 0 and rho is lesser than 1. Then we can find out the average number of customers, or you can say expected number of customers waiting in the system. Means in the queue as well as the one who is getting the service, that is L suffix S, can be found as rho divided by 1 minus rho. And then expected number of customers or average number of customers waiting in the queue can be found as L suffix Q is equal to rho square divided by 1 minus rho. This is also called as average queue length. Further, we can find out average waiting time of customers in the system, which is denoted by W suffix S, and that can be calculated as 1 divided by mu minus lambda, means inverse of service rate minus arrival rate. Average waiting time of customers in the queue can be calculated as W suffix Q, which is calculated as rho divided by mu minus lambda. The fluctuation of the queue length, or we can say the variance of the queue length, can be calculated as rho divided by 1 minus rho the whole square. Then finally, the probability of queue size being greater than or equal to n can be calculated as rho to the power of n and denoted by probability of greater than or equal to n. Now we will do one numerical problem which is related to this particular model. A TV repairman finds that the time spent on repair job has an exponential distribution with mean 20 minutes. If he repairs TV sets on first come first serve basis, and if the arrival of sets is with an average of 15 per 8-hour day, what is the repairman's expected idle time each day? First question. Then second question, obtain the average number of TV sets in the system. Obtain the average number of TV sets in the queue. Fourth question, what is the average waiting time of TV sets in the system? What is the average waiting time of TV sets in the queue? What is the probability of having 5 TV sets in the system? We'll start the solution in our next slide. Primarily, we need to identify the model. We may notice that the service or service time follows an exponential distribution. So I'll say first, since the service time follows an exponential distribution that is specified in the question, it implies that service rate will follow Poisson distribution. Then it says, if the arrival of sets is with an average of 15 per 8-hour day, it is given. It is not specified about the probability distribution, so that will be assumed to be a Poisson distribution. Means arrival rate is considered to follow Poisson distribution. I am simply writing it as PD. Okay, then the question talks about first come, first serve, means Q discipline or service discipline. Q discipline or service discipline is clearly specified in the question itself as FIFO or first come, first serve basis. Then, and they didn't specify anything about our calling source population. So I will say, and they didn't specify any restriction about the number of customers allowed in the system. Since number of customers allowed in the system is not specified, it is considered to be infinity. Then even the size of the population, the size of the calling source population is not being addressed. And hence, that will also be assumed to be infinity. Then the question talks about a TV repairman, which means a TV repairman indicates that it is a single server. Implies one server. So hence our model, our queuing model will be Poisson distribution, the arrival rate, service rate is also Poisson distribution, and it is a single server and FIFO basis, thus Q discipline or service discipline, and then there is no restriction, so I'll put it as infinity. Nothing is addressed about calling source population, I'll address about. So after identifying model, we can use those appropriate parameters, means we can use those formulas to calculate whatever is being asked. So first of all, given, let us see, service time is given as 20 minutes. Or I will say mean service time. Mean service time is 20 minutes given, which means service rate will be 1 divided by 20 TV sets per minute. So if I have to convert it into hours, I will say service rate, which is denoted by the symbol mu, will be, since I'm going to convert it into hour, I will say 60 divided by 20, and that will be 3 TV sets per hour. Right. Then the question talks about arrival of sets with an average of 15 per 8-hour day. They gave us arrival rate, which is denoted by lambda, that is given as 15 per 8-hour day. So 15 by 8 TV sets per hour. because I already divided it by that 8 hours. So it will become per hour. So we got now lambda value as 15 by 8 and mu value as 3. Let us move on. So we will calculate now rho, which is nothing but lambda divided by mu. Lambda, just now we saw it is 15 by 8. So 15 divided by 8 divided by 3. And that will be 15 by 8 into 3. So that will give us 5 by 8. Now, what are the questions being asked? What is the repairman's expected idle time each day? So this row, whatever we calculated, this is our utilization, service utilization factor. Therefore, P naught, that means probability of 0 TV sets in the system will be 1 minus the utilization factor, 1 minus rho, which is 1 minus of 5 by 8, we get 3 by 8. Therefore, our idle time will be, total working hours is 8 hours, multiplied by the probability of 0 TV sets in that, we get 8 into 3 by 8, so we get 3 hours as the idle time per day, idle time per day. So that is our first part of the question. Let us move on. Obtain the average number of TV sets in the system. So we have to find out L suffix S. L suffix S, we know it is rho divided by 1 minus rho for this particular model. And that will be 5 by 8 divided by, we already calculated this 1 minus rho, which is 3 by 8. So we get ultimately 5 by 3. That will lead to 1.67 TV sets approximately. I put it as, let me rub it and this is approximately 1.6. Then let us move on. We need to find out next one is obtain the number of TV sets in the queue. So that will be L suffix Q, Q length basically, and which is rho square divided by 1 minus rho. Rho square means it is 5 by 8 the whole square. 1 minus rho we already calculated, it is 3 by 8. So we get 25 by 64 multiplied by 8 by 3. So we get, this goes with this 8 times, we get 25 by 24 and approximately it will be 1, you can say 1 TV set. Then the fourth question. What is that fourth question? What is the average waiting time of TV sets in the system? Means we need to find out W suffix S, average waiting time in the system, which is 1 divided by mu minus lambda, means service rate minus arrival rate. 1 divided by, we already know service rate is 3, arrival rate is 15 by 8. So we get 1 divided by 24 minus 15 divided by 8. So we get 8 divided by 9. 8 divided by 9 means this is in hours. Next, fifth question is, what is the average waiting time of TV sets in the queue? We need to find out WQ, and that will be rho divided by mu minus lambda. which is 1 divided, sorry, rho is 3 by 5 by 8, 5 divided by 8, I'm sorry. By 8, and this is 3 minus 15 by 8. So we get 5 by 8 multiplied by 8 divided by 24 minus 15 will be 9. So this and this gets cancelled. We get 5 by 9th power. That will be your waiting time in the queue per TV set. Then last one, what is the probability of having 5 TV sets in the system? So sixth question, we are supposed to find P suffix 5. P suffix 5 will be 1 minus of rho times rho to the power of 5. 1 minus rho, we know it is 3 by 8. Rho is 5 by 8 to the power of 5. So if we calculate that, we get 0.036. That will be the solution for this particular problem.